So it's recording. Let me get started. All right. So basically, as I said last time, as we saw last time, basically what we're going to look at here are linear functions. That's the kind of function in this chapter, at least, we're going to focus on. There is a more general concept of functions in mathematics. It's not, and it is a very important concept. Actually, it comes out when we're studying relations and relationships between different quantities. There's also function notation, and there's also, as we'll see, different ways to represent a function. We'll see actually more than one way to represent one. And again, in particular, we're going to look at linear functions. Linear functions, you'll see, those are just functions whose graphs are straight lines, except vertical lines. But linear functions do pop up a lot, okay, as we'll see. And again, I did go over this last time, so I don't want to spend too much time on this slide again. But all around us, there are relationships between different quantities. For instance, there's a relationship between height and age. Okay, that happens. Same thing with height and weight, there's a relationship. Another one is how much exercise you get and how healthy you are, right? There's other variables to consider, but there is some kind of relationship between the two. Generally, up to a point, the more you exercise, the more healthy you are. Up to a point, there is such a thing as overtraining. But that's a different story. There's also, of course, as we know, grades and study habits and sleep and energy level. There's lots of relationships out there between different quantities. A lot more than I listed here. I don't know if you guys have studied economics or not, but I know there's this notion of supply and demand of something. There is a relationship between there, right? I think as one goes up, the other goes down, if I remember correctly. Now, those are relationships, but in this here, for now, in this chapter, let's just take a look at special kinds of relationships called functions. So functions are relationships. They're just special kinds of relationships, as we'll see again today. Okay, so basically when you're dealing with relationships, like height and age, for instance, those are quantities that can change value as time goes on. So there are certain quantities we're going to be dealing with where certain values will change. And because of that, those are going to be variables. So we will, in particular, work with variables. And, I think we actually saw this already, but in other math classes, you might have seen this also. But when you have variables like in algebra, letters X and Y can be used. Usually it depends on the context that you're studying, where you'll see, if something is a constant or a variable. A constant is something that doesn't change value. Like the number 1 never changes value. Okay, but generally X and Y are going to denote variables, as we'll see. And again, there's going to be relationships between different quantities. The idea is, with functions, one quantity will depend on another. So for instance, with what's a good one? With exercise and how healthy you are. Okay, the amount of exercise, how healthy you are will depend on how much you exercise. So there's some kind of dependence going on between different quantities. The one that depends on the other, that's what we call a dependent variable. So that's the one that actually depends on the other. And what's going to happen with these functions, as you'll see, if you haven't already, basically a function is going to take in input, and for each input, it's going to get output. And it turns out the variables that depend on something else, on the other quantity, those will be the output. The other variable, the one that's being depended on, is the independent variable. The independent variable. You'll see lots of examples, so I hope it makes sense what I'm trying to say. I hope it does. But that's what's going to happen, though. With functions, it's going to be a relationship where one variable, called the independent variable, you feed the function some kind of input, kind of like when you put something into a computer, like when you type something. And for each input, you get back an output. The output, that's what the dependent variable will be. That's going to happen with a function. Okay? And now let's actually formally define what a function is. There we go. So a function is a rule for a relationship between two quantities. Again, one is independent, the other is dependent. The dependent one depends on the independent one. And the idea is that for each value you put into the function, for each value of the independent quantity, the function will give you only one value for the dependent quantity. In other words, only one value for the output. So I guess if you want, if we go back to that age and relationship idea, I'm sure there is a function relating the two, but the idea is, let's say we take age as our independent value. That would be our independent, and the height would depend on age in that case. And for each age, you would get a certain height that you're supposed to be, let's say. Again, this is hypothetical. So I'm not saying this is true. I'm just trying to help you understand what a function is. But for each age value, you're only going to get one height value. And the function is the rule that tells you how to get the height from your age. In other words, how to get the output from your input. That's really the idea behind what a function is. I know it's a little confusing. It's not an easy concept, and I really hope I'm explaining it well. I just reproduced the definition up here. What's going to happen, this is really just notation, this slide. Generally, with those independent variables, which is, as I said, I did say this before, it's going to be our input for our function. That will generally be denoted by x. So x will be the independent variable, and that's what's going to go into the function, input. Let's see something. Let me just say this, that if it does freeze up, use the raise your hand feature or speak into your microphone. I mean, I don't think it's done that lately, but just in case. Okay? I forgot to say that earlier. We said independent. The dependent variable, okay, that is what comes out of the function. That's our output. The idea, again, is that for each value of our independent variable, the function is going to give us a unique value for our dependent variable, output. For each input, you get one output, and y denotes the output. Generally, people use this notation for a function. They'll use f, g, or h. I mean, there are other choices, but the most common are f, g, and h. I've seen other notation like capital F, capital D, capital G. It really depends on the context. And generally, also with this notation, you're going to see something like this. And this is just saying that the function f takes x as your input and gives you back y as your output, which is really what I'm trying to say over here. So f is the rule, whatever it is. It's going to take in your input, and for each input, you get one output back. And this is just sort of a visualization of it. You can almost think of this green circle as, I guess, some machine, I guess, if you want. X is going into the machine, into the circle. The function does some crazy, process, whatever, algorithm, I don't know. But for each X, you get back a unique output. Okay. Now, there is a lot of vocabulary associated with functions, and this is just one of them. I don't remember if the book says this or formally defines this, but the collection of all your possible inputs, in other words, the collection of all your possible values for your x, that's what we call the domain of the function. It's all the possible input, all the possible things that can go into the function. And they give an output that makes sense. And the collection of all your outputs, that's what we call the range of the function. So we have domain, we have range. I mean, there is a lot more functions I can do, but again, I really just want to stick with the book, what they do. Of course, I'm not going to reproduce the book. I'm just trying to explain things in my own words as well. But we have that notation. Okay, so let's consider some examples. Again, in math, you're not really going to learn much unless you do examples, okay? Not just you guys, but anyone, including me. So for instance, let's let f be a function that's telling us how many days there are in each month. So just to establish some notation, I'm going to let x be the independent variable. So x is going to be the month, January, February, whatever. Okay? And what's going to happen is your output would be the number of days that's in the month, the number of days. So for instance, again, this is what I was saying, x could be January, May, April, whatever. And then our output, y, that's going to be how many days there are. So again, we have y equals f of x, where f is somehow just taking in months as an input, and it spits back, and it's giving you back how many days are in there. So we can, as before, write y equals f of x. Now, how do we actually, what is f exactly? That is, how do we display what f is doing? There's different ways of doing that. One is with a table. So this table is just giving you some different values of input and output for the function f. So this is just giving you some input and output. There's actually a lot of different ways to specify what f is doing. One way is through a table. I mean, I didn't list all the months here, of course, but this should give you the idea. So if x is January, there's 31 days in January, right? So the function gives you back 31. For September, there's 30 days there, right? So the function gives you back 30. For August, right, it's going to give you back 31 because there's 31 days in August. Depending on the year, February might be 28 or 29. I think there's like a leap year that does that, things like that. Okay, I just got to stop this because I have to pause the recording because if it's longer than 15 minutes, YouTube will have a problem uploading it. So let me just